Well, this package comes from New Jersey. The door control I have not looked at before. Comes from a guy. And he says, "Thank you for looking at this. I am unsure exactly where the other tech shorted the 120 volt power and the board looks undamaged. I can only guess that the 120 volts shorted from the motor wire to the board into what I believe is the J2 connector. Any help or advice to buy a new board would be greatly appreciated." Well, we're going to see if we can fix this. This is a little weird contraption made by Stanley, and I have never seen one in person. I've seen it online. They have a very, very high price tag on it. Pricey price tag. They like that, folks. So, I'm not really concerned that I've never worked on one of these before. Electronics. Everybody should know how to work on electronics. If you're a tech, you should know how to fix it and figure it out. Stellar job at taping this. Man, fantastic, really. If you're going to be sending me door controls or whatnot, this is the way you need to do it, folks. I tell you, I am really impressed. There's a lot of people that just send stuff in with newspapers and that's it. Oh, look at this. This is really cool. Wow. Yeah, I have never actually seen one of these before in person. So this is going to be really new and interesting. It looks like the MC521, but it's definitely not. Wow. That's your motor connection. The red count, you have your three connectors there. It shows you what they are. This is what the MC521 looks like in reference. Similar in design. Almost similar in length. J5 and J4. There's the fuse. Couple capacitors. Coil. Interesting. Commercial operator. I'm not sure exactly when this was actually manufactured. But Stanley will show that on here. They'll have a manufacturer's date. They always do. Say like, usually it's up here. Now this is the Pro version of it. And they did not include that, from what I can tell. Interesting. I mean, that might be some type of code there, but... Well, maybe we will, maybe we won't get lucky and figure out what the date on this is. 2 screws are missing. Got 1 screw here. Now he said the J2 connector, which I don't see a J2. I see a J4, J5, J6. Oh, that's their encoder. Alright. He said, well, there's no output to the motor. I'm not sure exactly what's going on with the electrical tape. I'm going to take and peel back. Let's lower you down so you have a good view here. Wow. Guess I can't put the screw in the case, can I? I think they tried taking it apart, and they did. Okay. And there's the capacitor broken. Alright. Well, folks, if you need help in repairing anything, please don't hesitate. Allow me to fix it for you instead of trying to figure it out on your own. It's 3 standoffs. That's what the board looks like. I'm going to do a little pan. Really, really interesting. I will note that this Q10 right here, it looks pretty smoked. I'm gonna guess that's probably where it got touched. So, let's take the standoffs off. This looks like a crossbreed between 521 and a Durglide slider. Or a, could be just a swinger. Not sure exactly what it is. I think it's a swinger. Instead of the new install, I don't have my tool with me at the moment. So, this is what I'm doing. I don't think this will fit. It will. Alright. That was cool. Alright, so C31 is missing because it got broken off. They had electrical tape. Very similar in design. And that's what the bottom looks like. You can see what the case looks like. Appears to have some rust. That's interesting. Alright, let's flip it around. It does say Stanley. This is from 2006. So this is a newer controller. That's wild. Okay, 2006. And so these 521s were developed, not this particular one, but the one before it. The yellow ones were developed in before 2005, or at 2005. So, it kind of gives you an idea of how they're heading. Let's see. I don't see any Stanley markings on here. This might have been the first batch or something, that 521 Pro versions that they did. I am not really sure. I just dumped all my screws and stuff. Anyway, we're not here to talk about the Pro version. I just kind of want to get a timeline and see where this was developed and stood at versus the other one. Two big old coils, and they seem to still have problems with a hearing. There's some silicon RTV. They never learned their lesson about that. This is better than zip tying them. Kind of a very odd, obscure looking device here. Granted, I'm just looking at this at face value. I'm not. See, there's some rust here. So I will have to clean the rust up, make sure the parts are not bad, and see what happens. I'm gonna out some stuff. This really makes me kind of curious where he was sitting at. Much like the other ones, This here is your power connector J6. I don't imagine this is a dual operator. We only have one rev count. But it could be a factor of whether it's left hand or right hand operation. Looking at this again, here's your power connector. It should be like a 5 amp fuse, usually that's what it is. And these are your motor connectors. I'm guessing this meant for like left and right hand. We only have one encoder. I don't imagine that's going to be so this is where your power goes in. These are where your motors would be. I'm guessing this is, I don't think it would be a dual operator. I could be wrong. It is a dual operator. It's motor 1, motor 2. Okay. Door speed, door check. Three amp fuse. So this is a dual operator for, so this replaces your dual magic access. This is what this is. This is the update version. I gotcha. Now I understand. They went with the same layout as the MC521 Pros. Still kept the same ST chips for the processor. I still don't see anywhere where it would be that they took and shorted anything. I just do know that there's some rust here that we need to take care of and some oxidation here. I will have to see. I can't get into the relay. I don't imagine that was going to be bad. We're going to check Q13. We're going to check D22. The varistors and stuff look fine over here. Looks to be the same style or same part as the others for the Pros. I'd have to look at that closely. A lot of grease on it, so I can't really see. It's shiny. No, it's not the same part. Like K3568, I think is what that part number is. I don't know what this is because it's got a heat shrink on it. So, okay. We could take and give this a run. There's your, this is a resettable fuse here. I'll have to check these. These are all fuses here. There's a lot of rust in here, and I don't know why. Why would you have rust? Was this set outside or something? Kind of a no-name brand looking capacitor. Probably, I don't know, Nichion or something. Doesn't look too terrible, but could be worse. Yeah, so rust on this here. Q10's got some oxidation here, it looks like. C31 they knocked off. Bridge 2, BR2, got some rust going on with it. Same with this capacitor with C41. The crystal, got some rust going on it. This was supposed to be a new install, and they had all kinds of stuff happening with this. I don't see any evidence of the 120 going anywhere. I mean, they would have to have the box, the door would have to be running. The only thing they said, there was no output. Which, if you burn up any one of these transient suppressors or transistors, you're going to have problems. I'm betting this is probably, we'll clean this all up, clean all this all up. We don't find anything shorted. I'm betting that's all it's going to be. Cool. Alright, we'll take a look at this closer. I don't see any other like big bridges other than these down here. These are your opto amps. L1249. It's the same program buttons for this. And there's your header pin that will probably program the chip. 72F521M9T6 is what that part number is. Alright. I'll put it aside for now. I'm going to fix this, all these corrosions and rust, and put the capacitor back on. And come back with an update. So I was looking at this and it said, I'm re-looking at this in the process of eliminating problem. I can only get the 120 volts shorted from the motor wire to the board into what I believe is the J2 connector. Alright, so this is the J2 connector, which is your rev count. From here to here, that is ground. Okay, so let's look and find VCC. There's VCC. Let's see if we have a short on VCC. We don't. That's great. Okay, so let's find, okay, that was VCC. This goes through a trace and goes to this resistor here. Or to this one. That one goes to there. And it reads 1K, which is what it should be. And this one goes to this resistor, R16, and it reads the same. Now let's see where R16 goes. Does it go to ground? It does not. It did not go to VCC either. So let's see where R16 goes. Not on pin 1, 2, 3, 4, 5. It goes on 5. Okay. So this is an HCT 14 chip here. The buffer chip is what this is. So that means it points all this data is coming over here, going through this chip, and this chip is now sending that data to the processor. So if I was going to change the chip to potentially fix this problem, that would be the chip I wanted to fix and change. Now the motor circuit looks to be fine. I measured all the fuses here, and they were okay. We do not have any shorts on VCC. As I measured, there was 2K in resistance. I'm going to measure here just to see the bridges. I don't imagine we're going to have any shorts over here to the bridges. I did measure this bridge here, actually this one here because they had rust and I didn't see any shorts. Let's look at this real quick. And there's nothing there. Now I did want to see if I could find the voltage regulator, which should be, I would imagine, these guys here. Now I can look at the part number and see what they are. It says reading OL, 0L, it's overload. So it's 150K, and it's reading 12K. Resistance is higher than 200K, and I'm reading 1.9K. I believe that's 1.9, or is it 10K? Yeah, that's 2K. Alright. So, let's do this. Since I already know this pin here, this pad here, going to pin 16 or pin 14 of this chip goes to this one here. So that would make it this here. So we know this here goes to VCC. And we'll look and measure and see if this is VCC. And neither of them show VCC. This also could mean that it's going through a resistor or through the transformer. It has to be a high resistance. But I did want to track that and see where the VCC is coming from. I guess I can come over here. Let's just go back to here. We'll see if we can find VCC. That's charging up the capacitor. Alright, I'm not really finding VCC. Interesting. I'll take a look at this some more and get back with you on that. Still need to take and clean the circuit board up, and I'll get this chip here changed. I may just power it up and see what the display shows and go from there. Definitely see something here, but I'm not sure exactly what that is. I don't know if it's just corrosion or rust or like a mark, like it got hot or something. Definitely weird. Got a blue tint to it. That would be U19. You can see it in the reflection there. It's interesting. So if I got this powered up, I can see if there was actually any VCC coming to that chip or to the rev count. So I know where positive and negative is, and if there isn't, then I can take and see where I can find out where potentially where VCC is. Usually those are going to be your U17 and U19. Those are your voltage regulators. And then I would believe that that should be what you need to measure. Unless BR4 or MBR3 is something that's we should pay attention to. Do a quick measure of that while we're here. No. Okay. Well then. Strange. This is the only one that's actually shown anything for any significance. This ground does not connect to this negative. This ground does. So that tells me bridge 2 is in the circuit. Exactly what that told me. And that will probably have some resistors in the area. Okay, I'm going to follow this trace. And the trace goes to here. I can see the vias. This via and this via here are connected. These two are connected. Gotcha. The other one goes to switch. Okay. So these two here are connected. So the bridge goes to U19. And I don't know if that means it comes from it or to it. Let's take a look at the, let's find that pin 16 again. I believe it would be this pan. Could be wrong. What about the one over? There we go. Alright. We got capacitor right in there. And I know this should be ground. I need to take and look up the regulator itself and see how this works. Let's look and see at pin 2. Yep, there's ground in the center pin. That was right. So okay. Let's see if this feeds anything to this. That should be your ground. But it doesn't. Two separate circuits. And this via here goes to that third pin, and it does. Now where does it go from here? It's straight down underneath the switch here, which will be straight up. Go here, and it does. And then it goes test point 109 and into here. Okay. Into C24. Right here. And it does. And there's your positive there. Okay. And it goes over here. And it does. And there's your bus bar for your positive. Gotcha. And this goes over here, R57. I don't want to break the board. It does not go to R57 because it just stops before R57. And it goes over to the connector underneath TB2, which I'm not sure where we go from there. But I can speculate that these are still not connected. Okay. At least I have an idea of path of VCC coming from the bridge 2 and its filter cap C42, which I don't know if whatever this is, could be U16, is, yes it is. So I got my positive there. Gotcha. And there we go, bingo. So this is the regulator for these chips here. And I'll show you for that one as well. I'm pretty sure it's probably the same for that one. Cool. Like I said, this is the first time I've seen this controller. I've seen it online, but I've never held one in person. And I'm just kind of going through and see what I need to find out. I will solder some wires to this. It should be standard, same wiring for 521. I can still figure it out, I believe. These connectors here is the same. So I'm guessing that's probably your neutral wire. You're not going to plug in your DC into here. So. Or that could be the earth ground. That's probably what it is. And then the others, I'll just figure it out. We got this one here going into here. Just goes to capacitor. Actually, that one doesn't. Yep, that's a capacitor. Goes to one side of the tap. Transformer. And then this one here. So if we figure out, okay, there's the fuse. Alright, so here's your hot coming in through the fuse. This has got to be your neutral. And imagine this was probably earth ground. I just go through the coil. So it's not earth ground. So what is connected to here? Alright. Interesting. I'll have to see if I can find a wiring diagram online. That does get power to the coil. And we do have the fuse. So we might have two hot coming in and neutral and earth ground. We'll figure it out. Anyway, I'll probably get this chip ordered. I'm going to wire this up, plug it in, measure my voltage here, make sure I still got the good voltages. If I don't, then I'll pull this chip off and then measure again. If I do get the voltages after that, then I'm going to change that chip out. It's a good thing that they put this chip in between the rev count and the buffer chip that isolates the processor from anything shorting out directly. Looking at a photo online, this is your hot, this is your earth ground, and then this is your neutral. I'm not sure exactly why there's this spot here left open. Now this is in the manual from Stanley, so this is actually connected to the coil here. That could possibly be that this can operate with 240 volts. That actually might be what this is all about. So we have a 240 volts if we have this power up. So that makes more sense. Okay. Cool. I'll get this powered up. So I got my hot, my neutral here, and then we'll measure VCC here. It'll just be from this pin to this pin. And this would be your ground, and this is going to be your positive here. Speculating that it's probably either 5 volts or I don't imagine it's going to be 3.3 volts. Either 5 volts or 12 volts is what I'm going to guess the output of this should be. LM2940S, approximately 5. So I'm guessing that's probably 5 volts. We'll get it wired up, plugged up. We'll measure the voltages, see what happens. Now I'm going to attempt to put the capacitor back on, C31. I have not connected power yet. I just put enough solder on there to make anything worth anything. So I'm going to add a little bit more solder. There. And after we get this soldered on, then I will take in, turn power on. I don't have a fine tip on this right now. It's being a little bit difficult. But we will get it on. I don't suspect that this capacitor has any great significance of what this is going to cause the work or fail. Alright, we are secured. I'm taking, getting any debris off from underneath. My voltmeter plugged in. And we'll see. You know, I can just take in, go ahead and plug these two in here. So this is ground, got the pin 2, and then this one should be a positive. So that should show me voltage coming out of the rev counter or J2. You're seeing 0 volts here because there's nothing applied to it yet. I still have the plug in my hand. And I'm going to have to take and find an empty plug down below. Give me a couple of seconds. Okay, so we're going to plug this in and hopefully nothing blows up. We had 0, it shows 4.96 volts. Now we have, it says breakout. Okay, so that's good. Now I'm going to take and we're going to make sure that our regulator is regulating. I guess I could leave this in here for ground purposes. That's 4.96 volts. This is good. And I'm going to unplug this real quick. And I needed to find out which one went to pin 5. I wanted to see what the voltage is on that. Because the voltage is midway. 1, 2, 3, 4, 5. Let's just check this real quick. I think this was going through R16. Okay, so what was going through R16? Okay, pin 5. I was right. I can just put it on here and measure from ground and see what the voltage is. Plug it back in. If the logic is not correct, then you're gonna have issues. 4.96. So you got 5 volt coming to the rev count, so that's good. That looks fine there. Just need to take and clean up all the rust and stuff. And as far as the output goes, you can measure, see what that shows. We'll put it on 200 volts DC, and I'll have to take and look at the image again online and make sure I got this plugged in correctly. Now I got this plugged in over here to the motor, and it should be where, this may be in reverse, but it should be where the voltages are at for your hot and negative. I would imagine it's going to measure something. It's not going to do anything while it's in breakout. But I thought perhaps maybe something would show up real quick. Let's add a jumper so we can bypass this breakout and see what happens. Okay, so that was actually saying that the door was closed. Now we're going to look at this here. We have the test switch here. Pot 9 is for time delay for the vestibule for the second door. You have open time, this is your time delay. You have your open position, stall force. You have your door speed. You have your check speed. Okay, so I'm just curious. They do have it set, just to make sure. The double dots on here show where they would be at, where it's set at. There's no time delay apparently. It's turned all the way down. Open position is kind of halfway. Everything else looks fine. This one here, stall force, is not too far. Well, it's interesting. I'm just going to clean everything up. And I'm going to try to activate it and see if it actually will do anything. And it likely will tell me that there's an encoder issue. I do not know if I could take and make some type of resistor deal where I can take and send pulses, or what I can do. But I'm going to see if I can go from here to here and short this out, which is going to be your operate pin 1 and 2. It may not likely do anything because we don't have anything connected to your auto, ground, and hold open connection here. So I may have to take and put jumpers in a connector or something. See what happens. I'm just going to try to shorten out 1 and 2 on TV2. I'm going to measure the voltages here and see what they act like. Yep, see how I was reading it upside down. Doors closed. That looks like it's trying. I don't know. I've never seen one of these, so I don't know what exactly it's doing with the 0 and the 1, 0 and the 1. It's 2. Like I heard a relay click. Here's your activate. Okay. We'll put a jumper here for the auto and see what happens. Alright, so I have it in the auto. Apply power. And now we're going to take and activate it. We got voltages output, so that's good. So I know the motor circuit works. Good question would be, does the rev counter circuit work? Wish I could take and measure that if needed. It wouldn't be a problem. So I know we have output. That's going to be the only other thing is something that's in their wiring or the rev count is not correct. So if they took and had that jump into their J2 and it shorted out into the rev counter itself, the rev counter is bad. There's possibly nothing wrong with this. I can go ahead and change out that chip there and send the controller back, but they're going to have to get the rev counter fixed in that operator. So this is going to conclude this video. I don't think I have much more here to talk about. It's been kind of fun and interesting to see this operator, this controller, I mean. I hope you found this interesting. Thanks for watching. I'll see you next time.